All right, hi everyone. So what I'm going to be doing today is just going over the stuff that we went over earlier, the revisiting unit circles and word problems. So if you weren't there in class earlier, or if you just needed me to slow down, you needed to rewind, pause, fill out that worksheet if you want, you can do that now. So what I'm going to be doing is I am going to share my screen. Alrighty, so hopefully we can all see what's happening here. So the agenda for today was to finish revisiting the Unit 1 unit circle word problems. Then we went over the syllabus, then we talked about test corrections. If you have any questions about that, about the syllabus or the test corrections, let me know. The syllabus just provides the classroom expectations, what units we're going to be covering, my contact information, stuff like that. And then the test corrections, hopefully you all received the email that said scores released. You click on the scores released email. It'll give you your score, however many out of 70 points. Click the little view in blue, and then it'll show you which test questions you got incorrect, and you can just correct those for me. Show me your work, write it on a piece of paper, take a picture of it, and then however many points on the test that you corrected, you'll get 50% back on the test. So let's say you got 30 points correct, then fix those 40 points, right? 70 minus 30 is 40, right? So fix those 40 points and you will get 20 points back on the test. That is a lot. Okay, so this is a good opportunity to boost your grade. If you feel that you need to, please start off on a strong foot, right? We have a lot of other units and there's a lot of other assignments and a lot of other tests, so start strong while you can. Now, let's move on. Let's talk about the unit circle and word problems. Hopefully these things feel familiar because we have reviewed them on several occasions at this point, and we do have other PowerPoints on them, which I will be referencing. So let's start off with the unit circle. Okay, so the unit circle. All we're doing is we're combining the three elements that we are pretty familiar with in mathematics. So we're pretty familiar with right triangles, right? We're familiar with the Pythagorean theorem, with right triangles, with triangles in general. We should be pretty familiar with the XY plane. That's the second element, right? And that's right here. Hopefully you can see the mouse, right? Here's our X and our Y plane, a graph, and different points on a graph. And then we're also combining the third element, which is a circle, and all of the 360 degrees within the circle. So you can see right here, and we always start right here over on the right side, and we move counterclockwise around till we get back to 360 degrees. All right, so we're going to combine all of this together when we're creating a unit circle. So it's going to look something like this. All right, notice, right, that the radius of this circle is 1 unit, right? You see here, this point right here, where this arrow is meeting the circle. This point right here is the radius, right? The radius is the point from the center of the circle to the outside, to the circumference. So this is our radius right here, and it's 1 unit long. How do we know this? Because it starts at the origin and it goes to the x value 1 and 0, right? And you can see that for all of these 90 degrees that we go, these multiples of 90, right? It's always 1 unit. And it's not just at these 90 degrees, right? It's not just right here that the radius is 1. The radius is 1 at any angle within the circle, not just the initial side, but at any point, if you're going from the middle of the circle to the outside, the radius is 1. Keep that in mind. Now, we have to ask ourselves, where's the triangle? And here it is. So I've displayed it for you. So if we put the radius up here, right, from the middle to the outside of the circle, our radius is 1, right? This is going to be what is called our terminal side. So we have an initial side, and I'll get to that in a second. We have the initial side down here, and we have our terminal side. Our terminal side becomes the hypotenuse of our triangle. And this is why I said that the triangle is imaginary, right? You can see right here, right here I said it's imaginary right triangles, because we're basically imagining an x and a y value. We're only going to be given this terminal side right here, right? But we're going to imagine this x value, we're going to imagine this y value, and that's going to give us our coordinate point right here on the graph. So our coordinate point is always on the circle. Okay, not in the circle, not outside the circle, on the circle, on the circumference. Right, and our radius becomes our hypotenuse for this triangle. You see, here's one short leg, here's the other short leg, and then here is our hypotenuse. Our hypotenuse, again, just as a reminder, is always our longest side in a triangle, and it's always opposite of the right angle. Okay? Now we're also going to use the reference angle when we're forming a triangle. This is going to be important, right? The reference angle is right here. It's in royal blue. Everything is color coordinated. I hope you noticed. So our reference angle is down here, and our reference angle, if you remember from our previous videos, is always between the x-axis and our terminal side. In this case, our initial side and the x-axis are the same, right? So our reference angle looks the same as our theta. But for now, just keep in mind, we're using this reference angle to form this actual triangle. All right, and then the x value and our y value, again, become the point on this graph. Okay, so that's something that we would draw in. Normally, we're just going to be given this side, and we have to draw it in ourselves. Okay. So now, we need to consider the fact that, right, this is up here in the first quadrant, but this can apply at any degree within the unit circle, right? So here we see the terminal side, there's a typo here, haha. The terminal side shows how many degrees we're going in the circle, right? And this is our theta. Okay, so we're starting at our initial side right here in yellow, and we're going this many, we're opening up all the way, right? We're opening up this angle all the way, we're down here in the third quadrant now, right? And we're gonna stop wherever our terminal side stops. Terminal means end. To terminate something is to end it, right? So the terminal side is where our angle terminates, where our angle ends, where it stops, okay? So our theta right here goes all the way around. Notice our reference angle though is still this small little guy right here, and it's between the x-axis and our terminal side. And we use this as our reference point, and then we create our little triangle right here, right? So our x value right here is in magenta, our y value is in orange, and you see that creates our point down here. So notice that on this side of the graph, our x value is going to be negative. And actually, also on this side of the graph, our y value is negative down here in the third quadrant. So that's one thing to notice, okay? And hopefully that feels familiar because we did talk about quadrants in a previous video. All right, now this was one question on the exam, or not the exam, on the assessment. I should call these things their right names. This was one question on the assessment that I think threw a lot of people off. Now, this is in the formula sheet, so if you studied the formula sheet, you could have gotten this correct. If not, that's okay, we're doing it now, right? So, we're always gonna go based off of our reference angle, and we're gonna use our reference angle right here in blue, and we know that our sine in SOHCAHTOA, sine equals opposite over hypotenuse. So in this case, when we're using this reference angle down over here in this little corner, our opposite side is going to be our y value. And actually, if you're using the reference angle, your y value is always going to be your opposite side, okay? And so that means that our hypotenuse is r, right? So sine equals y over r, right? We're using this angle, opposite side, y over r. For cosine, we know it's SOHCAHTOA, right? So CAH, cosine equals adjacent over hypotenuse. So if we're using the reference angle, our adjacent side is x, and our adjacent side will always be x if we're using the reference angle, okay? So our cosine is equal to x, our adjacent side, over r, our hypotenuse. And then tangent is opposite over adjacent, which is always going to be y over x. So when I ask you, right, when I ask you to define these functions in terms of x, y, and r, this is all I'm asking. What's sine? Well, you say it's y over r. What's tangent? It's y over x. That's all. Okay, that's all I needed for that question. Okay, also notice that you can do these same things for cosecant, secant, and cotangent, right? You just do the reciprocal, all right? But wait, this is a very important point, okay? If r equals 1, then that means that we can replace r with 1 in these definitions, right? So if sine equals y over r, and r is equal to 1, then sine is just y over 1. And y over 1 is just equal to y, right? Because 20 divided by 1 is 20. 3 divided by 1 is 3, right? So that means y divided by 1 is just y. So that means sine equals y. In other words, our sine in our unit circle, and that's why it's especially important in the unit circle that our radius is 1. In our unit circle, our sine value is our y value. And then the same thing goes with cosine, right? Cosine equals x over r. Well, if r equals 1, then cosine equals x over 1. And x over 1 is just x. So that means cosine equals x. So that means our cosine is our x value. This is why a unit circle is so important. And also, just throwing it in there, tangent is going to be equal to sine over cosine. All right? So this is a really key point that I want you to understand. That these coordinate points right here, this x and this y, that this x coordinate point is your cosine value for whatever theta you've created, and that your sine value is, and that your y value is your sine value for whatever theta you created. So let's say this is like 45 degrees right here, right? This point on the circle, this xy point, is going to be cosine 45, sine 45. I'll get to that in a second, okay? And that works with any point on the circle. And that's what makes the unit circle so special, is that at any given point on this circle, you can find all the possible combinations of cosine and sine for all 360 degrees in the circle. All right, this circle represents, I'm going to say it again, this circle represents all of the possible cosine and sine values for all of the 360 degrees in a circle. Okay, cool. So now here are some special triangles, and hopefully you remember these. We talked about them before. If not, you can check those other PowerPoints out just to see the proofs on why these are the way that they are. But we're going to look at the 30, 60, 90 triangle, and we're going to look at the 45, 45, 90 triangle. So keep in mind that in our unit circle, our hypotenuse is always 1. So looking at right here, the 30, 60, 90 triangle, so that's the top one here in the dark red, right? Our hypotenuse is 1. When our hypotenuse is 1, for this type of triangle, our shorter side is always going to be equal to 1/2. And our longer side, not the longest side, because the longest side is the hypotenuse, but the longer leg down here is always going to be equal to √3 over 2. Okay? Always. If it's a 30, 60, 90 triangle and the hypotenuse is 1, the other two legs will always be 1/2 and √3 over 2. Always. Okay? Now, same thing goes with the 45, 45, 90 triangle. It's down here in the dark purple. Okay? The hypotenuse is 1. When the hypotenuse is 1, the other sides of this triangle are always going to be equal to √2 over 2. Okay? Always. As long as this hypotenuse right here is 1, in a 45, 45, 90 triangle, these sides are always √2 over 2. Both of them. Okay? So now, how does this look like on the unit circle? We need to ask ourselves. Well, it looks like this. So here, going back right here, right, you see this dark purple 45, 45, 90 triangle. I'm placing that on the graph for you right now. I'm placing that on the unit circle for you. So here's our 45, 45, 90 triangle. So you can see, right, back here it said this bottom side is √2 over 2. This side over here on the right is √2 over 2. Same thing goes here. Our x value at the bottom here is √2 over 2. Our y value going up is √2 over 2, and that's exactly what this coordinate point here represents. And we just talked about how our x value and our y value are the same as cosine and sine. So that means that the cosine of 45 degrees is right here, √2 over 2. The sine of 45 degrees is right here, √2 over 2. And then the same thing applies for all of the multiples of 45 degrees in the unit circle. Okay, it's the same exact triangle, it's just flipped over the different axes, right? It's just reflected. Okay, so here it's the same triangle, it's just flipped. Here is the same one, flipped, flipped, right? This is still a 45, 45, 90 triangle, especially if you're using the reference angle, right? So what this over here means is that the cosine of 135 right? Because our hypotenuse is always our terminal side. So we're looking at this right here. Our cosine of 135 is negative root 2 over 2. Or if we're looking down here at, we go all the way around to 315 degrees, right down here, right? Our sine, for example, of 315 is negative root 2 over 2. You don't even need a calculator. You know it by heart now, right? Isn't that so cool? Okay. So now, enough of the 45, 45, 90. You can see all the multiples are written out right here. So we had 4 different triangles. Let's take a look at the multiples of 30. So here, down here, we have our 30 degrees. Up here would be our 60, and right here is our right angle, is our 90. So this is a 30, 60, 90 triangle. And you can see at this coordinate point right here, our x value is the longer side, so it's root 3 over 2. Our y value is the shorter side, so it's 1/2. So what does this mean? This means that the cosine of 30 degrees is root 3 over 2. You can plug it into your calculator, I promise. It's root 3 over 2. And this means that the sine of 30 degrees is 1/2. Again, you can plug it into your calculator, and it will be true. So the same thing goes for the other multiples, right? We're turning this on the side. So now instead of looking at the 30 degrees, we're looking at the 60 degrees. 30 degrees is up here, right? So this is now a 30, 60, 90. Our x value is the shorter side. Our y value is our longer side. All right, so that means that for cosine of 60 degrees is 1/2. And that sine of 60 degrees is root 3 over 2. And the same thing applies for all of these other multiples of 30, and they're all listed here on the side. So let's say we're going on this circle, and I ask you, hey, what is the sine of 300 degrees? Well, you can tell me, right, that 300 degrees is down here. The sine is going to be our y value, and this is the longer side. So I just know at the top of my head, and we're down in the 4th quadrant, right? The sine is going to be negative, right? Because y is negative in the 4th quadrant. So it's the longer side and it's negative, so it's negative root 3 over 2. Sine of 300 degrees is negative root 3 over 2. You don't even need a calculator. You just know it. You just know it. Okay, so enough of that. Let's move on to word problems. I need water. So I tried explaining word problems to everyone before. I'm not sure if it really resonated or if it stuck with anyone, just because we did do it on a Friday, and I know that Fridays don't feel like actual school days sometimes. We are going to have to get in the habit of actually utilizing Fridays the way that we need to. So let's start with word problems. There's 2 key terms that I want you all to keep in mind, okay? There's the angle of elevation and the angle of depression. Okay, so the angle of elevation, you can see over here, it's outlined with the royal blue color, okay? It is measured from the ground up. So you start off with a horizontal line at the floor, and then you elevate. That's why it's called elevation. Elevate, like an elevator, you go up. All right, so you start at the floor and you go up until you reach the hypotenuse of your little triangle that you make. So when you make a word problem, you're going to draw it out, you're going to draw a triangle, you're going to find a triangle in this drawing somehow, and then you are going to measure from the floor up to the hypotenuse. That is your angle of elevation, and it's always inside the triangle. You see, this is inside. The angle of depression is a little bit different. Okay, so the angle of depression, you're actually starting at the tip top of the triangle. You're looking out, creating a horizontal line, and you're measuring downwards from the outside of the triangle. I didn't need to click that yet. From the outside of the triangle down towards the hypotenuse. So notice this angle is outside of this triangle that we have formed here. Okay? Now, there are 2 ways that you can solve word problems that use the angle of depression. You can either use the complementary angle right here. So if they give you this angle, you know that right here is 90 degrees. So you can just subtract this angle of depression from 90 degrees. You'll find the complementary angle. Now you have a side inside of your, now you have an angle inside of your triangle, and you can just do some trick, right? You can just do a function and you can find whatever side you want of this triangle. Or if you use a little bit of geometry proofs, what you can do is you can actually take this side and prove that it's the same as this angle right here. Sorry, this angle up here in orange is actually the same angle down here. Why is that? Alternate interior angles, right? This horizontal line going out right here is parallel to the line at the floor. And then there's a line that intersects, so we know that alternate interior angles are the same. So then you can use this angle down here to solve your missing side, or you can use this green angle up here to solve your missing side. It's up to you which way you want to do it. So really quickly, these are the steps you're going to do when you're given a word problem. Draw it out, first and foremost. Draw it out, label as much information as they give you. Then just ask yourself, what do they want me to find? Based off of what you have and what they want you to find, pick a trig function, and then just set up and evaluate your equation. All right? So if you feel like you don't know where to start, this is how you start. Draw it out, label, what do I find, which trig function do I use, and then set up the equation, okay? So here's our example. A nursery plants a new tree and attaches a wire to help support the tree while its roots take hold, okay? An 8-foot wire is attached to the tree and to a stake at the ground. From the stake in the ground, the angle of elevation of the connection with the tree is 42 degrees. Find to the nearest tenth of a foot the height of the connection point on the tree. Okay? So your drawing is going to look something like this. It does not have to be this detailed. It probably won't be this detailed, and that's okay. All right? So ask ourselves, what do we have now? All right? Well, they gave us the angle of elevation down here, which is 42 degrees between the floor and the connection to the tree, right? That's what they said. And then they gave us the length of the wire, right? They told us that's 8 feet. And as you can see, in our little right triangle, this 8 feet right here, this is our hypotenuse, okay? And we're looking for the height of the connection, right? So how far up the tree does this wire go? And if we're looking at this angle down here, that height just so happens to be our opposite side in our triangle, right? So if we are looking for the opposite side and we have the hypotenuse, so we have O and H, we have to ask ourselves, which trig function do we use? Well, SOHCAHTOA. Which of those has O and H? So, sine, right? Sine equals opposite over hypotenuse. So that's the one we're going to use. We're going to use sine, and we're going to find opposite over hypotenuse, and let's figure out the height of this connection. So this is all we do. We just plug it in at this point. So we do sine of 45 degrees, plug that into your calculator, make sure you're in radian mode. Make sure you're in degree mode. Oh my God. Learning radians tomorrow. That's on my mind. Make sure you're in degree mode for right now. Make sure you're in degree mode. Okay. Sine of 42 degrees is equal to, I had 40 degrees right here, is our opposite, which is our x that we're still trying to find, divided by our hypotenuse, which is 8 right here, right? That's the length of our wire. So when you plug in sine of 42, again, make sure you're in degree mode, you'll get 0.6691. That's going to be equal to x over 8, and all we do, right, is just multiply both sides by 8 to get x by itself. So then 8 times 0.6691 is approximately 5.4 feet. Yay! That's all there is to it. So that means that right here, this side of our triangle is approximately 5.4 feet. So now we know how far up this connector goes on the tree. Okay. So now let's try an example where we're doing the angle of depression. So here's our example. It says, from the top of the fire tower, a forest ranger sees his partner on the ground at an angle of depression of 40 degrees. If the tower is 45 feet high, it's been a long day. If the tower is 45 feet in height, how far is the partner from the base of the tower to the nearest tenth of a foot? All right. So that means it's going to look something like this. So there's a fire tower, right? The angle of depression looking straight downwards is 40 degrees. The height of the tower is 45, and then we're just trying to find out how far this partner is from the tower. Okay. So we have our angle of depression, we have our height, we're looking for the distance. We need to ask ourselves first which method we're going to use, and then also which function. So for the function, we need to ask, well, what sides are these? We have both of the legs. We don't have the hypotenuse. The hypotenuse isn't part of this equation, which means we're not going to use sine and we're not going to use cosine, because cosine and sine both require us to have information on the hypotenuse, which we don't have. So that leaves us with tangent, right? So we're going to use tangent, and now we need to pick which angle we're going to use. Are we going to do complementary angle? Are we going to do alternate interior angle? Well, here's both. So it's up to you, whatever preference you want, okay? Whatever is easiest for you. If you want to do the complementary angle, that's right here, right? So all you do is 90 minus the 40 degrees that they gave us. So that's 50 degrees. And now we find out that this angle inside of the triangle here in royal blue is 50 degrees. And we said we're going to use tangent, right? We can't use sine, we can't use cosine, we're going to use tangent. So the tangent of 50 degrees is going to be equal to our opposite side, which is our x, right here that we're trying to find, divided by our 45, which they gave us. All right, tangent of 50 is equal to 1.1917. And then we just multiply that by 45 to get x by itself, and we get that x is approximately 53.6 feet. So that means that this distance right here, that this person is from the watchtower down on the floor right here, is 53.6 feet. All right, and you can see right here, we're going to get the same exact answer using the other angle. So let's see how that looks. So if we do alternate interior angle right here, right, it's 40 degrees up here is our depression, our angle of depression. So that means that this angle right down here on the other side is also 40 degrees. All right, notice now that our opposite and adjacent sides have now switched, okay? So we're doing the tangent of 40 degrees, and our opposite side now is going to be our 45, and our adjacent side is going to be our x. So notice here how tangent of 50 was x over 45, while tangent of 40 is going to be 45 over x. You see, x over 45, 45 over x. It's now switched because we've switched which angle or which perspective we're looking at. All right, so we're just going to do some arithmetic right now. We're going to plug in tangent of 40 degrees into our calculators on degree mode. We're going to get 0.8391 is equal to 45 divided by x. Multiply both sides by x. Divide both sides by 0.8391. And so then we get 45 divided by 0.8391. If you plug that into your calculator, you are going to get approximately 53.6 feet. Okay? So that's all there is to that. Done. Awesome. Okay, so I'm going to stop sharing real quick. I'm just going to finish up a few notes. Now I'm just going to wrap up my thoughts. I hope that this presentation helped a little bit. If you want a one-on-one or you want me to draw things out on the board for you a little bit more, let me know. If you have any questions, please feel free to reach out. You now have all my contact information in the syllabus. Again, if you're going to do test corrections, do those. Those are going to be due Wednesday morning. Yeah, that's all for me for now. Okay, have a good day. Bye-bye.